If you were unfortunate enough to be the victim of a crime or taken ill unexpectedly, you might think that surrounded by all these people, someone would intervene. After all, isn't there safety in numbers? Psychologists say no. Research suggests that often a victim is less likely to receive assistance when surrounded by a group rather than a single bystander. When people are in a crowd, it's easier to pass the buck. It's what psychologists call the diffusion of responsibility. Liverpool Street Station in London, a busy thoroughfare for commuters. Unknown to these passers-by, Peter is an actor. As part of an experiment on bystander apathy, he's pretending to be ill.
Help! Help!
How long before he gets help?
Please, somebody. Help! Help me, sir. Please help me.
Helping would be inconvenient or even risky. He lies there for more than 20 minutes and no one raises an eyebrow.
Please, somebody help me.
It's always very distressing to watch situations like this where people are obviously suffering and no one's actually helping them. But what we have here is two conflicting rules. One is the rule that we ought to help, and the other is the rule that we ought to do what everybody else is doing. And here you have effectively a group of strangers who are exerting the pressure not to intervene, not to help, and it's very difficult to rebel.
The bystander effect is a psychological concept that explains why people may take longer to help another person in distress when there are more people around. But let's suppose we're led to suspect that a second factor might affect response times: the gender of the person witnessing the emergency. A researcher was interested in examining the bystander effect in the context of how a person's gender may affect response times of the witness. To that end, she assigned people to observe a person in distress. The situation is established so that participants don't realise that the situation is part of the study. The situation is manipulated so that there are 0, 5 or 15 other people present when the emergency takes place. The dependent variable is the time it takes a participant to intervene in the situation, to help in the situation, and that's measured by the number of seconds. If the participant hasn't intervened within 90 seconds, the participant receives a score of 90. Now, it just so happens that when we conduct a Factorial ANOVA, we're interested in a few things. The main effects, as I said before, which describe the impact of each factor or independent variable on its own. And there's also the interaction effect, to the extent, which is the extent to which differences in the levels of one factor are the same at each level of the other factor. So we've got 6 different groups representing all the combinations of our independent variables. So we've got 4 males who witnessed a person in distress with no other person present. There are 4 males who witnessed a person in distress with 5 other people present. And there are 4 males who witnessed a person in distress with 15 other people present. And we also had the same for females who witnessed a person in distress. And these scores are the time it takes to respond to the person in the emergency situation. So the higher the score, the longer it took, or the longer amount of time it took to respond to that person in distress. So we've got 6 different groups of people, and for each a time it took to respond to the emergency situation. Now, to explain the main effect and the interaction effect, I have to tell you what a Factorial ANOVA is doing. So when we do a Factorial ANOVA, we will see that we will have a total variability in response times. This is the total variability of each score from the grand mean. And then we slice this total variability into 2 parts. So one of the slices represents the variance explained by the different groups or cells. A cell in a Factorial ANOVA is a group of participants who are treated alike. For example, the females in a group of 5 people responding to an emergency. Now, the variability of each group or cell from the grand mean. This is the variability from each group or cell from the grand mean. Another slice represents the variability or the error among individuals within each group. It's the variability of each individual in the group from the group mean. So we have a chunk of variance that's explained by what we do to the different groups, and we have another chunk of variance which is the error. So that is the variance in response times that can't be explained by the variables that we've manipulated. So up to now, this is exactly the same for the explanation of how a one-way between subjects ANOVA is petitioned. That is, the variance accounted for by the model and the variance not accounted for by the model. The only difference here is that the model gets petitioned up into an effect on the first factor, in this case the number of people in the group, and an effect on the second factor, in this case the gender of the person helping, and their combined effect or their interaction. So when we have more than one factor or independent variable, we just get the between groups variance subdivided up between the main effects and the interaction effects. So when we do a one-way ANOVA, we get one F ratio. But now we're going to get 3 F ratios when we do the between subjects factorial example. So when you do this in SPSS, you get a table like this. The tests of between subjects effects table reports the outcome of the ANOVA that we've just done. This is also known as the ANOVA summary table. It gives us all the information used in the calculation of the F statistic. As you can see, it gives us several sources of variance. We'll focus on only 3 sources, which are the between groups variance of people, which was the number of people in the group, the between groups variance of gender, so that was the gender of the person who was helping in the emergency, and the variance that involves the interaction of these 2 factors. Note that the intercept, which always needs to be included and will invariably be significant, is rarely of interest, as it tests the null hypothesis that the grand mean is 0. So there are 3 rows that we actually need to pay attention to in this table. One of them shows the main effect for the number of people, just the number of people present on its own. The other is the main effect of gender, so the gender of the helper, and the interaction effect between the 2 factors. For each source of variance, we've got the sum of squares, which is computed. This is the sum of the squared deviations of each factor and their interaction from the grand mean. The degrees of freedom column lists the number of degrees of freedom associated with each source of variance. The mean square is the actual variance of each source. To get this number, you divide the sum of squares by the degrees of freedom. The F ratio, and that F ratio is taking the mean square of the effect and dividing it by the mean square of the error. So the F represents the ratio of the effect that the model can explain to the error in the model. So if you have a look at gender, we can see that the mean square of the effect of gender is 57.04, and the mean square of the error, which is a variability within this group around the mean of gender, is 16.74. The ratio of the effect of gender by the error within gender gives the F statistic of 3.408. So you can see that there's no significant effect on gender. The significance value is 0.081, which is above the alpha level of 0.05 that we normally choose. However, there is a significant effect of the number of people in the group. The significance value is 0.000, which just is saying to 3 decimal places it's less than 0.001. There's also no significant interaction effect. The significance value is 0.497. So let's have a closer look at what the main effects is and what it actually means. The main effect of people. What does it mean to say there's a main effect of people which is significant? Well, imagine if we had not measured gender of the person, or in other words, we just lumped them all together. And all we know is that we had a bunch of people who were exposed to a person in distress by themselves, with 5 other people and 15 other people. And they're in the boxes that you can see. So all the people who witnessed a person in an emergency by themselves was placed in this box. So this box includes males and female helpers. And the same was done for all the people who witness a person in an emergency with 5 other people present. And they were put into this box. And at the same time, those who witnessed a person with 15 other people present were in this box. Then we calculate the mean of each of those groups, or each of those boxes that we place those people. So the main effect is like doing a one-way ANOVA on those 3 means to test if those 3 means are different from each other. So what you might find is that there is a significant main effect of the number of people who witness a person in an emergency situation and their time to respond to this person's cry for help. So what does that tell us? So what that tells us is that these 3 means are different from each other. We don't know which means are different from each other at the moment, so we'll have to do some sort of post hoc test to find out, and I'll talk about this a little bit later. So looking at the graph, it becomes pretty obvious where the difference is, but we'd need to do some more formal tests to check this out. So time to respond to an emergency seems to increase, by the looks of it, when there's more people present. So if you break your leg in the London subway, it's best if you break your leg in the London subway when there's no one around, or when there's one other person around, rather than it being in peak hour. What about the main effects of gender? So we're pretending that we don't know the number of people in the group who witnessed the emergency. So all we're doing is we're just clumping or lumping all the people together, the zeros, the people alone, the people with 5 others, and the people with 15 other people present. We're just lumping all them together, and we're just looking at whether the gender of the person who's helping has an effect. So all the male helpers were placed in this box, and the same was done for all the females who were placed in this box. Then we calculate the mean of each group. And then what we're going to do is in the Factorial ANOVA, in the main effect of gender, it just compares those 2 means. And what you might find is that there's no significant main effect of gender on the response time to respond to this person's cry for help. So what that tells us is that the 2 means are not significantly different from each other. And when looking at gender, the F ratio would tell us that there's no significant effect. Again, you can see this very clearly on the graph, where there does not appear to be much difference in response times across males and females, and the 95% confidence interval bars are almost totally overlapping. What about the interaction between the number of people in the group and the gender of the helper on the time to respond to an emergency? Now in the SPSS output, it was clear that there was not a significant interaction effect. There was a non-significant interaction between gender and the number of people who witnessed an emergency on the response times in that emergency. So you can look at this lack of interaction in the following way. What's the effect of gender at each level of number of people present in an emergency? So when there's no other person present, what's the effect of gender on response times to the emergency? You can see that when the person's in distress, the male's response times are longer than the female's when there's no other person present. What about when there are 5 other people present? You get a similar result, a similar difference, just by eyeballing it. So when there's no other person present, when there's 5 other people present, there sort of isn't a gender effect. Now what happens when there are 15 people present? Well, when there are 15 people present, you actually get a smaller difference between males and female response times. But this is not enough to say that there's an interaction effect going on. In the accompanied SPSS video, I run through the analysis of this Factorial ANOVA in much more detail.